Hello guys, and welcome to my tutorial. In this tutorial, we're going to go through 0417 ICT chapter 4, which is networks and the effects of using them. So this is chapter 4 of your syllabus. If you're a student who's preparing for the May June exams, if you're writing your IT exam on the 8th of May, then this tutorial is for you. Or if you're a student whose exams will be in November, October, November, this is also very helpful for you. So let's jump right into it. So this is networks and the effects of using them. Networks and the effects of using them. So in this tutorial, we are going to go through the operations and purpose of the router. We're going to go through common network devices. We'll go through Wi-Fi and Bluetooth, cloud computing, common network environments, network types, security issues regarding data transfer, common network devices, passwords, other authentication methods, anti-malware software, and finally, electronic conferencing. So let's look at some common network devices and terms used in networking. We have the network interface card. Then we have the media access control address. We have internet protocols. We have data packets. So what is a network interface card? Basically, a network interface card is a hardware device inside, any device that is able to connect to the internet or to connect to a network. So without your network interface card, your device cannot connect to a network. Okay. Then we have a wireless network interface card. So it's the same as a network interface card, a NIC, except a wireless network interface card uses antennas and can connect a device to a network wirelessly. By the way, the MAC address is embedded on the network interface card. We're going to discuss about the MAC address as we go on. So here is the media access control address. It is a 48-bit number, and it is divided in groups of 6, and it's a hexadecimal value. Hexadecimal meaning it's a base 16. As you have decimals are base 10, binary is base 2, so MAC address uses hexa values which are base 16. Okay, you don't have to go into details about hexa values and the number of bits, but you just need to know that a MAC address is a device that uniquely identifies. It's a number that uniquely identifies a device, okay, on a network. And usually the MAC address does not change. If you want to change the MAC address, then you will have to change the network interface card altogether. So the MAC address, the first group of digits, the manufacturer's code, and the last group are the device serial number. Then we have an IP address. So an IP address is an address that identifies the location of a device on a network. Okay, so unlike a MAC address, an IP address can change if you change the location of a device, okay, from one network to the other. So an IP address can change depending on the location of the device, but the MAC address does not change. Okay, you can look at the MAC address as maybe your DNA. Okay, your DNA will not change even if you relocate from country to country. It still remains the same. Whereas your like your physical address where you stay can change if you shift from one house to the other. So that's how you can look at this. So really the IP address, the device that looks at the IP addresses is the router. Okay, so because the router will check the location of the device. So for example, if you send a message from one organization to the other organization, for your message to reach the other organization, it is going to pass through intermediate networks or intermediate routers. So the intermediate routers are going to check the IP address. Okay, if that message is meant for their organization, they're going to accept it. Otherwise, they're going to forward it to the next router till it reaches the correct organization. So the main router of that organization is going to check, and if the IP configurations match that address, they're going to accept, and then that particular message will be routed to the correct device. Okay, I hope that's clear. Oh, and then we have, okay, so the IP address, this is usually assigned to the computer by the internet service provider. So internet service provider, these companies that provide internet services. For example, if you're in Africa, if you're in Zambia, we have internet service providers like, yeah, we have Starlink, we have MTN, we have Airtel. Okay, so those are your ISPs. So the router, we said the router looks at the IP address, whereas the switches really, they form a table, okay, looking at the MAC addresses. So a switch looks at the MAC addresses, but a router will look at the IP addresses. So an IP address, that's an example of your IP address. It looks like that. So now let's look at the data packet. What's a data packet? So we've talked about the MAC address. We've talked about the IP address. So all these are rules or protocols that followed for us to be able to connect computers together and for these devices to be able to communicate. So we have data packets. So data packets are the smallest units that are transferred over a network. So your data is broken down into packets, okay? So a data packet has got the following information. So it has got the header, and then it has got the data. So the header of a data packet contains the sender's IP address, where the data is coming from, the receiver's IP address, the destination of the data, then the sequence or identity number of the packet. This is to ensure that the packets can be reassembled in the correct order once they reach the destination. That's very important. And the packet size, this is to ensure the receiving station can check if all the packets have arrived intact. Then, and how many data packets make up the whole message? How many data packets make up the whole message? So this is just how the routing is done. So when the router receives a packet of data, it checks the destination IP address, okay, against the stored routing table. So it checks the destination IP address against the stored routing table, which allows the router to determine the packet's next step in the path. So a data packet will pass through a number of routers before it reaches its final destination. All the information in the data packet headers allow the data packet to be reassembled in the correct order according to the sequence number by the receiving station. So that's just how packets are routed. Then we have other devices like the hubs. So a hubs are hardware devices that can have a number of other devices connected to them. They are used primarily to connect devices together to form a local area network. Often in the same building, a hub will take a data packet received at one of its ports and broadcast it to every device connected to it. So the takeaway here for hubs is it broadcasts. What does that mean? Whatever it receives on one port is going to send to all the devices connected to its ports. Okay. So because data packets are delivered to every device on the network, hubs are not very secure because every device will receive every data packet. So it's not good. It compromises security. And then there will be unnecessary traffic on the network, which results in reduced bandwidth. So there will be traffic on the network because it's forwarding to devices that are not, meant to receive. Okay, so causing traffic. Then we have switches. So basically, a switch looks like this, and a switch is an intelligent version of the hub in that it is going to check the data packet, okay, for the destination device. Okay, so it will check and forward the message or the data to the correct device. So a switch has got a lookup table that looks like this. It stores the MAC addresses of the devices connected to its ports so that it is able to forward a packet to the correct or to the next, to the correct device. Okay. So using the lookup table, a switch matches the MAC address of an incoming data packet arriving at one of its ports and directs it to the correct device. None of the other devices will see this data packet. Okay, thus if a data packet arrives at port 2 and the MAC address in the data packet is that, then the switch will connect the data packet to port 4 only. Okay, so the switch is smarter. Okay, so but the similarity of these two devices, the hub and the switch, is that they are both are used to connect devices together to form a network. So in summary, both a hub and a switch are used to connect devices in a LAN. Both hubs and switches use data packets. Okay, so those are the similarities. Hubs send data packets to every device on the network, whereas switches send data packets to a specific device only. So switches and hubs. So security is lower with hubs than switches. That's the difference. A switch uses a lookup table to determine the destination device. A hub does not do that. Switches use MAC addresses to locate the destination device. Okay, then we have something called a bridge. Bridges are devices that connect one LAN to another LAN that use the same protocol. Okay, they are often used to connect together different parts of a LAN so that they can function as a single LAN. So if you've got two separate LANs, you can create a bridge as long as these two separate networks are using the same protocol, meaning the same set of rules. So that's one example of the use of a bridge. We've got two LANs. Here is one LAN, and here is another LAN, and these are connected to a bridge to form one single network. Routers are used to route data packets from one network to another network based on IP addresses. So I said earlier that routers look at the IP addresses. So it can do this because each router has its own IP address. So routers are used to join a LAN to the internet. So if they ask which device is used to connect a computer to the internet, it is the router. So the router is responsible for connectivity to the internet. So each router has got its own unique IP address. And so when a data packet is received at one of its ports, the router inspects the IP address and determines whether the data packet is meant for its own network or for another. Okay. External network. If the data packet is meant for its own network, then the data packet is routed to the local switch or hub. Otherwise, the data packet is transmitted to a different router and therefore to an external network. So we went through this earlier. So the router will check the data packet. It will check the IP address. If it's meant for its own network, if the IP configurations are matching, then it's going to accept and route it to the next, to the nearest switch. Otherwise, if they're different, it's going to forward it to the next router, to an external network. So routers know where to send data packets by consulting a routing table, okay, stored on the router's RAM. So routers have got a RAM, okay, which stores the IP addresses of the devices, possible devices they can route the data packets to. So the routing table will contain information about the router's immediate network, okay, the immediate network, such as computer addresses and information about other routers in its intermediate vicinity. So the routers around it is going to have all that information. When a data packet reaches a router, it examines the IP address. Because the routing table contains computer addresses of all the computers or devices on its network, it will be able to work out that the data packet is intended for a computer on its network. Okay, routers, however, do not store the MAC addresses of devices. Only IP addresses of all computers and devices are stored. The router does not need the MAC address because the data packet will be sent by the router to the switch on the recipient local network. The switch can then use its lookup table to send the data packet to the correct device. So same thing I said earlier. So routers, they look at IP addresses and not MAC addresses. The switches are the ones that deal with the MAC addresses. All right. So let's compare comparison of routers and bridges. The main objective of a router is to connect various types of networks together. Okay, whereas the main objective of a bridge is to connect LANs together. Okay. Then routers scan a device's IP address. Bridges scan a device's MAC address. So also the bridges are going to look at the MAC address instead of the IP address. Then data is sent out using data packets for routers. Data is sent out using data packets as well for bridges. Then connected networks will use different protocols, connects networks together that use the same protocol for bridges. Then a routing table is used to direct data packets to the correct device. Bridges do not make use of a routing table. Then a router has more than 2 ports. A bridge has only 2 ports because it's just connecting 2 LANs together. Then we move on to Wi-Fi and Bluetooth. So both Wi-Fi and Bluetooth offer wireless communication between devices. They both use electromagnetic radiation as a carrier of data transmission. Bluetooth sends and receives radio waves in bands of 79 different frequencies known as channels. These are all centered on a frequency of 2.45 gigahertz for Bluetooth. So devices using Bluetooth automatically detect and connect to each other, but they do not interfere with other devices because each communicating pair uses a different channel from the 79 options. That's why we have 79 channels so that we don't have interference, even if we have a number of devices trying to communicate together using Bluetooth. So Bluetooth is useful when transferring data between two or more devices which are very close together, less than 30 meters distance, okay? It is useful when the speed of data transmission is not critical. If you don't care about speed, then you can use. Also for low bandwidth applications, for example, when sending music files from a mobile phone to a headset, okay? Then Wi-Fi sends and receives radio waves in several different frequency bands, 2.4 gigahertz. It can go all the way up to 5 gigahertz. The most common at the moment, okay, which is 5G. Like Bluetooth, each band is also further split into channels. The 5 gigahertz band has a faster data transfer rate, but a shorter signal range. Wi-Fi is best suited to operating full-scale networks because it offers much faster data transfer rates, better range, and better security than Bluetooth. A Wi-Fi enabled device such as a computer or smartphone can access, for example, the internet wirelessly at any access point or hotspot up to 100 meters away. So here is Wi-Fi and Bluetooth comparison. Transmission frequency used in Bluetooth is 2.4 gigahertz, and Wi-Fi can go up to 5 gigahertz. Then data transfer rate for Bluetooth is 25 megabits per second. Then Bluetooth can go up to 250 megabits per second. Maximum effective range is 30 meters for Bluetooth. Wi-Fi can go up to 100. It depends on the type of Wi-Fi router used. The maximum number of devices connected is 7 for Bluetooth, and Wi-Fi will depend on the device again. Type of data transmission security. Bluetooth uses key matching encryption. Wi-Fi uses wireless equivalent privacy and Wi-Fi protected access. Cloud computing. So cloud computing basically is storing the information on remote servers instead of storing information on your local computers. So we have a number of advantages and disadvantages of cloud computing, and we have different types of cloud storage systems. So let's look at that. So cloud computing, there are three common cloud storage systems. The first one is public cloud. This is a storage environment where the customer and cloud storage provider are different companies. So if it's you and then your cloud service provider is Microsoft, for example, then we're using public cloud. Okay, so because myself and Microsoft are two different entities. Then we have private cloud. This is storage provided by a dedicated environment behind the company firewall. Customer or clients and cloud storage providers are integrated and operate as a single entity. So if I've got an organization and we buy servers and then we create a cloud, then we call that a private cloud because the cloud, the same company that I own is providing the cloud services. So it's one entity, so that's called private. Then we have hybrid cloud. This is a combination of the two previous environments. Some data resides in the private cloud, and less sensitive commercial data can be accessed from a public cloud storage provider. Advantages of cloud computing. So clients, files stored in the cloud can be accessed at any time from any device anywhere in the world as long as internet access is available. So anywhere you go, you'll be able to access your data. There is no need for customer clients or clients to carry an external storage device with them, or even use the same computer to store and retrieve information. So if you're flying out to another country for a business meeting, you don't have to carry any device. Whatever device you find there, you can log into your cloud and then you'll be able to access your information. The cloud provides the user with remote backups of data with obvious advantages in the event of data loss or disaster recovery on their own computer, okay? Then if a customer or client has a failure of their hard disk or backup device, cloud storage will allow recovery of the data. Then one last advantage, the cloud system offers almost unlimited storage capacity at the price. Okay? So you can buy as much space as you like. Disadvantages of cloud computing, security aspects of storing data in the cloud. So there are security aspects because this data is only being handled by humans. So it is not 100% secure. Okay, your personal data is not secure. If a customer or client has a slow or unstable internet connection, they could have trouble, trying to access their information or their data. Then costs can be high if a large storage capacity or high download upload data transfer is required. Then the potential failure of the cloud storage company is always possible. This poses a risk of loss of all backed up data. Yeah, so it's possible to lose your data even on the cloud. So again, these are just advantages. This has obvious advantage. You do not need to carry memory sticks around with you if you want to access your files away from home. You do not have to pay for large storage capacity on your computer or mobile phone. Because the cloud is controlled by external companies, they will ensure that your files are backed up and therefore reduce the possibility of losing irreplaceable data. And the ability to synchronize files ensure they are automatically updated across all devices. This means that the latest version of a file saved on a desktop computer, for example, is also available on other devices such as a smartphone. Cloud storage is also ideal for collaboration purposes. It allows several computers to edit and collaborate on a single file or document, okay? Like Google Sheets, Google Slides, you can collaborate and work on the same file. So let's look at data security on the cloud. Companies that transfer vast amounts of confidential data from their own systems to a cloud service provider are potentially relinquishing control of their own data security. This raises a number of questions. Number one, what physical security exists regarding the building where the data is housed? Number two, how good is a cloud service provider's resistance to natural disasters or power cuts? Number three, what safeguards exist regarding personnel who work for the cloud service company? Can they use their authorization codes to access confidential data for monetary purposes? It's possible. They're only but human who work there. So if you're storing sensitive data on the cloud, it is not 100% safe. Okay, so data loss, it is very possible for you to lose your data. Then let's look at common network environments. We have extranets, intranets, and the internet. So these three. Most students get confused when we talk about an intranet and an extranet and the internet. Okay, so but these are very simple concepts. So let me just look let me just run you through these three. So let's start with the internet. The internet is a global network. Okay, it is a network of networks, interconnection of all the networks. Okay, coming together, and the internet is public. Okay, it's a public network. Then we have intranet, which is a private network. Okay, only people within a particular organization can access information on an intranet. Okay, so they make it private so that they can make rules um, and manage who can access what data. Okay. Then we have extranets. Extranets are private networks also, but they extend to other organizations. For example, if your organization has got another organization who supplies them with resources to run their business, then they might want to extend their intranet to the other organization, an external organization, to form an extranet so that they can easily collaborate and communicate. I hope that's clear. So that's the difference between those three. The network types, we have local area network, which is a network which covers a small geographical location like a single building or a single organization. Then we have a wireless local area network, which is a local area network, but it is connected without cables. Then we have a wide area network, which is um, it covers a larger geographical location like a country, a city, or even the internet. There are advantages of networking computers together using LANs. So the advantages is they allow the sharing of resources such as hardware, printers and scanners. They permit easy communication between users. They use a network administrator that ensures security and use of the LAN is constantly monitored. Okay, so that's the advantage of connecting computers together. So to share resources, to communicate, to share data, to have control of your devices and network. There are also disadvantages of networking computers together using LANs. Number one, easier spread of viruses through the whole network. Queues for shared resources such as printers, which can be frustrating. Okay, you want to print something, and there's a queue and you have to wait. Slower access to external networks. Okay, so you can have slower access to the internet if you form a network because you've got all these other users pulling your bandwidth. Increased security risk when compared to standalone computers. Yes, you can be hacked quite easily if you connect your computers together. If the main server breaks down in many types of networks, the network structures, the network will no longer function properly. Yeah. So if the main server breaks down, you have no access to the internet, for example, or you might not retrieve your information. I hope that's clear so far. Then we have wireless local area networks. Okay. So devices known as access points are connected into a wired network at fixed locations because of the limited range. Most commercial lands, for example, a college campus or an airport, need several access points to permit uninterrupted wireless communication. So this is a comparison between wireless and wired networking. It is easier to expand the networks, and it is not necessary to connect the devices using cables. Then using cables produce a more reliable and stable network. Wireless connectivity is often subject to interference. Yeah, so you can expand your computers easily if you're using a wireless network, whereas a wired network is more difficult to expand, but it ensures a stable internet connectivity because wireless is subject to interference. Thick walls, other devices communicating using radio waves, you know. Then wireless networking, this gives devices increased mobility as long as they are within range of the access point. So you can move around quite easily. Then wired networking, data transfer rates tend to be faster, and there will not be any dead spots. Okay, so you're going to have a reliable internet connection with wired networks. Then no cabling, so there is a safety improvement and increased flexibility. So no tripping over cables, and also might be cheaper because they're not buying a lot of cables. So for wired networks, setting up cable networks tend to be cheaper overall, in spite of the need to buy and install cables. Okay. There is an increased chance of interference from external sources for wired networks. Then data is less secure than with wired systems. Yeah, it's less secure because it can be intercepted. However, cable networks lose the ability for devices to be mobile. Yeah, so you're stationed in one position, you can move quite freely. Data transmission rate is still slower than for cable networks. That's for wireless. Then wired, having lots of wires can lead to a number of hazards, such as tripping hazards, overheating, and so on and so forth. Then wireless communication, it is possible for signals to be stopped by thick walls. Yeah, like I said. So that's really the difference between wired and wireless. So here we're looking at network issues and communication. So security issues regarding data transfer. So most of the issues were covered in chapter 8, okay, which is safety and security. Things like hacking, phishing, and farming. I also plan to do a video on these, especially viruses. I'm thinking they might come in your exam in May, June. So let's see what happens. So here, let's look at passwords. Passwords are used for, when you want to access your email account, in the password for authentication, when carrying out online banking, accessing social networking sites. Okay, we also have other authentication methods such as zero login. So we need to know what zero login is. We should be able to explain if that comes in your exam. And biometrics, magnetic stripes, or they're called magnetic strips. I hope I'm pronouncing that correctly. Then smart cards and physical tokens. Then lastly, electronic tokens. So let's see what zero login and biometrics are. So zero login essentially relies on devices being smart and secure enough to instantly recognize a user by a number of features based on their biometrics. Biometrics means bio for like biological features, okay? Some parts of your body to authenticate somebody, So that's what biometrics are, like fingerprint scans, retina scans, facial recognitions, and so on. Also behavioral patterns. So the reason why, computer scientists have come up with authentication methods such as zero login and biometrics is because a password is no longer, safe enough for authentication due to the mishandling of personal data over the years. So that's the reason. Then let's look at magnetic stripe cards or magnetic strip cards. Okay, magnetic strip cards are also covered in chapter 2 and 6. The cards have a magnetic strip on the reverse side. Basically, they've got a magnetic strip which has got some particles. Okay, now these particles can be North Pole or South Pole. So these particles represent the binary values of 0 or 1. As we know, computers use or understand binary values, which is on or off, 0 or 1. The strip is read by swiping it through a card reader. Data such as name, ID number, sex, and date of birth may be contained on a magnetic strip. When used as a security device to allow entry to a building, for example, access will only be allowed if the scanned data matches the data in a database. Some ID cards also use a holographic image. These are designed to make forgery of the card more difficult. So holographic images change color or appear to have a moving object as the image is viewed from different angles. Because these are difficult to copy, it prevents somebody simply photocopying a card and using it illegally. Another form of security is to have a photographic image of the card user printed onto the card surface. So that's how we can ensure that the cards are authentic and cannot be easily forged. Advantages of magnetic stripe cards. So now, this particular syllabus is full of advantages and disadvantages. So you need to pay particular attention to advantages and disadvantages of everything. So advantages of these cards, they are easy to use. It is not an expensive technology. The cards can be multi-purpose. For example, door key cards, network access cards are used in vending machines to buy food and drinks. Disadvantages of magnetic strip cards. Less secure than, for example, biometric methods. No encryption is used and the stripe contents can be copied fairly easily. So they are less secure. That's one disadvantage. The cards wear out with a lot of use because of the swiping. The cards tend to wear out over time. Magnetic readers often fail to read the cards on first attempt, so wastes a lot of time. And now let's look at smart cards. How different are they from magnetic strip? By inserting a tag, chip, and antenna into a security card, it can act as a smart contactless card. That is, it can be read from a distance and does not have to be swiped through a card reader. Okay. Obviously, if you're not swiping it through a card reader, it is going to be more durable. It will reduce the wear and tear on the card. The chip on the smart card can store data such as name, security number, sex, date of birth, and a PIN. Smart cards can therefore be used as a security device. If the card is in a wallet or a pocket, as the owner of the card walks up to a security gate, readers on either sides of the gate quickly scan the security data stored on the RFID tag embedded in the card. Now, RFID will be covered in some other chapter. This stands for radio frequency identification. So the user will then be invited to enter a PIN on the keypad. If all details match, then access will be allowed. Then we have physical tokens. What is a physical token? A physical token is a hardware device, okay, a token in a form of authentication. It's a solid object, okay? The user's interaction with the login system is used to prove that the user has possession of the token, okay? Physical tokens contain internal clocks And when a PIN and other authentication details are entered, then a one-time password is generated. The OTP is shown on a small screen. The code changes on a regular basis and is usually only valid for less than a minute. But we use banking as our example. A customer has logged on to the bank's website. They get to a web page which requires some form of authentication to prove who they are. To do this, they need to use a physical token supplied by the bank. So what do? The customer inserts their debit card into the top of the token device, first authentication step, and the device either recognizes the card as genuine or rejects it. The device then asks the customer to press identify and then enter their PIN. A one-time password is then shown on the device screen. This is usually an 8-digit code. A customer now goes back to their bank webpage and enters the 8-digit code. They are now given access to the account. So basically, a physical token is it's called physical because the customer will physically interact with a device. Okay, so you can take this example which was given here. So you can be home on your laptop, on your bank's website, trying to access your bank web page, and then it's going to ask you for a physical token. So for that, you have to drive down to your bank for a device. You insert your card, and then that token will be generated. So that ensures that the customer had physical interaction with the bank's device. Okay, so that's one method of authenticating a system. So this clearly enhances security because the thief needs to have in their possession the token device, a cloned card, and the PIN to allow them to gain access. This is a classic example of a multi-factor authentication method. So multiple authentication methods. So physical tokens, there are two types of physical tokens. We have a disconnected physical token. This is a type described above, where a separate device is used, requiring the user to key in data manually using a keypad. Okay? So if it's a disconnected physical token, is where you have a separate device used to generate the OTP. Then we have a connected physical token. This type of token transmits the generated one-time password directly to a computer through a USB connection. The user does not need to manually enter data. So a connected one is where the user does not need to manually enter the data. It is transmitted automatically, okay? Then a disconnected one is where you have to enter the data manually, right? Then we have electronic tokens. Electronic tokens are software installed in a user's device, such as a smartphone. Suppose a user wishes to log into a website using their tablet or computer. The website requires electronic tokens to be used to authenticate the user. The user has already installed the electronic token app on their smartphone. When the website requests the user to authenticate who they are, the user opens the app on their smartphone. The app generates a one-time password, which is valid for less than a minute. The user enters this OTP when prompted by the website, together with some other form of authentication, such as PIN, Touch ID, or Face ID. The website servers runs the same software as the app. Because both the server and the smartphone have synchronized clocks, they will generate the same numbers. Once the OTP and other form of authentications are verified by the website, the user will be allowed access. So I'll give you an example of Microsoft Authenticator. Okay, if you're trying to log into maybe Microsoft Office 365, you'll be required to use the Authenticator app, okay, to be logged in. Okay, the authentication app is going to generate an OTP which should match on the phone and on your computer to allow access. Okay, so that's electronic token. Then anti-malware software refers, we can refer to chapter 8. In this section, we will concentrate on the user. In this section, we will concentrate on the use of a type of anti-malware software known as antivirus software to protect devices against a potential virus attack. Antivirus software should be loaded onto a computer and then run to allow all software and devices to be scanned for viruses. So whenever data or software is downloaded or being transferred to other devices, it is essential that a virus check is carried out on that other device too. Okay, so let's just quickly run through how an antivirus software works. So this is general, okay, but different antivirus softwares can have different features on how they work, but generally they all have these features, the following features. They check software or files before they are run or loaded on a computer. Antivirus software compares a possible virus against a database of known viruses. So it keeps a log, a database of known viruses, then it checks, okay? They carry out heuristic checking. This is a checking of software for types of behaviors that could be a possible virus. This is useful if software is infected by virus not yet on the database. So they can check a software behaviors that indicate a possible virus, okay, for those that are not on the database. Any possible files or programs which are infected are put into quarantine, which allows the virus to be automatically detected or allows the user to make the decision about deletion. Any possible file or program which are infected are put into quarantine, which allows the virus to be automatically deleted or allows the user to make the decision about deletion. It is possible that the user knows that the files or programs is not infected by a virus. This is known as false positive and is one of the drawbacks of antivirus software. So it can call out a software that that is totally harmless to be a virus. So that's one of the disadvantages of antivirus softwares. Antivirus softwares need to be kept up to date because new viruses are constantly being discovered. Full system checks need to be carried out once a week, for example, because some virus lies dormant and would only be picked up by this full system scan. And let's move on to electronic conferencing. This section will consider 3 types of electronic conferencing: video conferencing, audio conferencing, and web conferencing. Video conferencing is a communication method that uses both video and sound. It is a substitute for face-to-face conference between a number of people who may be in different parts of the country or live overseas. It is carried out in real time and makes use of some form of network. Electronic conferencing. So we have video conferencing. The basic hardwares include webcams. You need a webcam, large monitor or television screen, microphones, and speakers. There are a few items to consider when a conference is about to begin. It is essential to agree a time and date for the conference to take place. The delegates in each conference room must log into the video conference system. The video conference setup needs to be checked before the meeting goes live. Webcams need to be placed. Webcams need to be placed in the correct position so that all the delegates in the room are within visual contact. The webcams will capture the image and then transmit them to the other delegates. They will see the images on their own large screens. There are a few items to consider when a conference is about to begin. Microphones need to be placed centrally so that all the delegates can speak. The sound is picked up by the microphone and transmitted to the other delegates. There are a few items to consider when a video conference is about to begin. It is essential to agree a time and date for the conference to take place. The delegates in each conference room must log into the video conference system. The video conference setup needs to be checked before the meeting goes live. Webcams need to be placed in the correct position so that all the delegates in the room are within visual contact. The webcams will capture the images and then transmit them to the other delegates. Okay, so that's what you need to check before the video conference begins. There are a few items to consider when a conference is about to begin. Microphones need to be placed centrally so that all of the delegates can speak. Okay, it is important for one person to be the main contact in each conference room to make sure each delegate is able to be heard. This is particularly important. It is important for one person to be the main contact in each conference room to make sure each delegate is able to be heard. This is particularly important if more than 2 video conference rooms are linked up at the same time. In addition to the hardware items described above, it is also important to realize that software plays an important role in a successful video conference. So here's what we need. This is just a log. So webcam and microphone software drivers. It is vital that the correct software is used to ensure that the webcam and microphone transmit the images and sound to the other delegates. Then the codec. Codec can stand for coder, decoder, or compressor, decompression, okay? The first is used to encode or decode the digital data stream to allow the data to be transmitted and playback. The second is used to compress the data before it is transmitted and then decompress it again at the receiving conference room. Then echo cancellation software. Echo cancellation software allows talking to take place in real time and permits the synchronization of communication. Microphones can pick up sound from the speakers, creating an echo. This software copies received signals and checks for parts of the signal that reappears but are delayed slightly. The reappearing parts are removed from the signal. The echo is removed. So it is important that all these are in check and all these are in place. So this is what happens, when as you are on a video conference. Okay, so the softwares themselves that we use, like Zoom, Google Meets, they've been created in such a way that they have got echo cancellation and the codec. This is what goes on in the background. It is coded. Okay, it is encoded, decoded, compressed, and then decompressed. Video conferencing, advantages of using video conferencing. As people are in their own building, it is much easier to access important documents or bring in experts at key parts of the conference. This would be difficult if they are a long way from their office. It is possible to hold conferences at short notice. Okay, conference dates can be set up within a few hours as no person needs to travel very far, so which is important. So short notice, and you can bring in experts at any particular time. Not traveling physically to meeting reduces costs, so reduce traveling costs, no need to pay for hotel accommodation or venue, or to hire a venue. It also reduces the cost of taking people away from their work for 2 or 3 days to travel. People are still paid their wages even though they are not in the office. So this is a large hidden cost. Okay. It may be better to use video conferencing than having delegates travel to potentially unsafe places around the world. For example, some countries are at war with other countries. So instead of sending people there, it's better to hold a conference. It is better for the environment. Less travel means less pollution. It connects people in an organization who might be otherwise left out. For example, people not based at the headquarters. Okay, they can still um, learn or take part in what the headquarters is doing using video conferences. Disadvantages of using video conferences: there's potential time lag in response, delays when talking. So that's a major problem with Zoom and Google Meets, especially if your internet connection is slow. Images can jack, usually due to poor internet or network performance. It can be very expensive to set up in the first place. Both the hardware and the software are expensive to purchase and get set up correctly. Uh, so yeah, buying a laptop or a computer is not very cheap. There can be problems if the delegates live in different countries where the time zone differences are large. Yeah, so for people maybe in the United States and maybe people in Zambia, uh, there could be a problem there because when it's day here, it's night there. When it's night there, it's day here, and so on. It can be demotivating for staff if they believe that one of the perks of their jobs is international travel. It can be demotivating for staff if they believe that one of the perks of their job is international travel. Yeah, so imagine the people love traveling on the job, and if they take that away from them, it could be demotivating. The whole system relies on a good network connection. If it breaks down or the signal strength is diminished in any way, then the video conference can be almost unusable. So these are some of the advantages and disadvantages of video conferencing. So like you see, IT theory is what we do in our day-to-day lives now, okay? So they ask you about video conferencing, think about Zoom, think about Google Meets. But as you know, you're not allowed to mention specific brands of softwares and stuff like that. But just think of the application and then answers can come from there, you know, like having to travel, you know, eh, if the place is unsafe, it's better to hold a conference and things like that. Then audio conferencing refers to meeting held between people using audio, so there's no video. Audio conferencing can be done over the standard telephone network, referred to as phone conference. The procedure to be carried out during a phone conference is detailed below. The organizer of the phone conference is given 2 pins by the phone company. One pin is a personal pin given to the organizer, and the second pin is a participant's pin. Okay. So the organizer contacts all the participants and informs them of their pin and the date and time of the phone conference. When the phone conference is about to start, the organizer dials the conference phone number, and once they are connected, keys in their personal pin, in this case, um, the participants then call the same conference number to join in. Once they get through, they each input the pin given to them by the organizer. Without this pin, it would be impossible to join the phone conference. Okay. The organizer of the phone conference is given 2 pins by the phone company. One pin is a personal pin, meaning theirs as the organizer, given to the organizer, and the second pin is for the participants. So the organizer contacts all of the participants and informs them of their pin and the date and time of the phone conference. When the phone conference is about to start, okay, the organizer dials the conference phone number, and once they are connected, the participants then call the same conference number to join in. Okay, once they get through, they each input the PIN given to them by the organizer. Without the PIN, it would be impossible to join the phone conference. So that's how that works. Pretty straightforward. Then the equipment required for an audio conference over a standard telephone network normally just includes a standard telephone. It is also possible to hold an audio conference using a computer as long as the microphones and speakers are connected. This makes use of the voice over internet protocol. It also, so voice over internet protocol, your WhatsApp calls, audio calls, so they also use voice over internet protocol, voice over IP. It is also possible to connect an internet telephone, which usually plugs into the router or other internet devices. In this case, equipment can include a computer with built-in microphone and speakers, external microphone or speakers, an internet phone, a standard phone. Using a voice over IP allows an organizer to create a group of people to take part in the conference call. The group is created by dragging and dropping user details in the group. So it could be different for different applications, but generally that's basic. Then we have web conferencing, often referred to as webinar or webcast, uses the internet to permit conferencing to take place. Multiple computers are used with this system, all connected over the internet. As with video conferencing, it is carried out in real time and allows the following types of meetings to take place: business meetings to discuss new ideas, presentations, online education, or training. The only requirement is a computer and a high-speed, stable internet connection. To carry out web conferencing, each user either downloads an application or logs onto a website from a link supplied in an email from the conference organizer. Some of the main features include of web conferencing: slide presentations using presentation software can be posted. The host's computer screen can be shared for live presentations. It is possible for any delegate to draw or write on a whiteboard using their own keyboard or mouse. It is possible to transmit images or videos using the webcam through the conference. Documents can be shared by first uploading them to the website before the conference begins. As described earlier, it is possible to chat verbally or by using instant messaging through the conference. So this is typical Google Meets. Okay, you can even do things like you can record the meeting, you can write something, you can drop a message, maybe if your internet connection is not strong, and so on and so forth. And the disadvantages and advantages really should be the same with video conferencing. Okay. So here you can see, as indicated earlier, there is crossover between web conferencing, video conferencing, and audio conferencing through the use of webcams. The built-in microphone and speakers, it is possible to have a conference using any device, which allows these functions. For example, tablets, smartphones would both permit this type of group communication. Okay, so there is a huge crossover. Okay, so this is quite easy to understand. That's it for now. I'm going to create other tutorials on storage devices, chapter 1 and chapter 2. So be sure to subscribe and click on the bell icon. Thank you for listening. Goodbye for now.